All right, welcome to lesson 6.2, grade 8. In this lesson, we're now going to change you from using tiles into what we call symbolic. Now, symbolic is simply letters and numbers, whereas tiles are, what we refer to as concrete materials. So you may have noticed that there are instances where using tiles are not a practical method of solving an equation. For example, for the equation 25x minus 375 is equal to 1875, are you ready to draw all those tiles? Probably not. Fortunately, in this case, we can turn to the symbolic method. So let's look at making a symbolic method and matching everything up so that you understand what's going on. So our first thing is, I want you to draw x plus 4 is equal to 6 tiles. So to do that, we need x and 4. Here's x plus 4 on this side, and 6 on the right-hand side. Now, obviously, its matching symbolic would be x plus 4 equals 6. So, to solve this, I've got to get the x by itself. That means I've got to get rid of these 4 there. Now, there's several ways of doing this. You can just simply subtract 4, or you can add 4 to both sides. I like to think of it this way. If you're adding 4, to undo adding 4, all we need to do is subtract 4. Or you can add 4 negatives. And remember, if you add 4 negatives to one side, you must add 4 negatives to the other. So down below, I've now got my x plus 4. But I'm not going to put 4 negatives with it. Come on, silly. Move over. Here we go again. All right. There's x plus 4, my x and my 4. Here, I have a negative 4. On the right-hand side, I did have 6. Okay. Now, this 6, you silly thing, is there, and I added 4 negatives to that. So here's my 4 negatives here. Now, the act of adding is this step here. X plus 4, I added negative 4 there. Or you could say I subtracted 4. Remember, negative 4 and subtract 4 are the same thing. On the right-hand side, I have 6, and I put a negative 4 with that side. Right? Now, the next step is the zero principle. I'm going to zero out this step here. They're gone. Whatever I do to the one-hand side, I've done to the right, so I need 4 to go over here. So there's 4 gone there. Now, what does that look like? Well, a negative 4 and a positive 4 gives me 0. And 6 take away 4 gives me 2. So there's my zero out step. The next step is to actually redraw it. So I've got x plus 2. Back up here, maybe I can copy that. No, I'm not going to be able to. Right, so go back here, x equals 2. So this is my x equals 2 step, and the zeros are gone. So my final answer basically is that x is equal to 2. So let's take a look at another one. You can see the solution is going to be the same either way, using tiles or using the other method, which is symbolic. So the rules of solving are very simple. First off, you have to figure a way to get the variable by itself. This is called isolating the variable. And the second rule is always to do whatever you do to one side, you have to do to the other. In order to isolate the variable, you always have to get rid of the added or subtracted part first. All right? So there's 2 ways of looking at this. All right? I like to think of it more of a holistic. What are you doing to the variable? Are you adding to it? Are you subtracting from it? Are you multiplying it by a number? Or are you dividing by a number? Those are the only 4 options you have. So you need to identify what is being done to the variable. Once you know what that is, once you know you're adding 3, you take and subtract 3. If you're subtracting 4, you add 4. If you're multiplying by 3, you divide by 3. If you're dividing by 6, you multiply by 6. So once you identify what's being done, the next step is to do the opposite to both sides. Okay? Now, if you don't remember, the opposites for adding is subtracting. The opposite of subtracting is adding. The opposite of multiplication is division. And the opposite of division is multiplication. So whatever you see happening, just do the opposite to it. Okay, let's take a look at the next page. So let's begin. Solving by addition. Here you see x minus 4 is equal to 6. So you should ask yourself that first question. What's happening to the variable? What are you doing here? In this case, we are subtracting 4. That's our first step. So now, I need to take and do the opposite of subtracting, which is adding. So this is what I have to do. I have to add 4 to both sides. What does that look like? Well, I've got x minus 4 equals 6. So my x minus 4 stays there, just like I had tiles drawn there. I'm going to add 4 to it. I had 6 here, so now I'm going to add 4 to it. Now, negative 4 and a positive 4, those are your negative tiles and positive tiles, they become 0. 6 plus 4 is 10, so x is equal to 10. So now that you have a solution, there is a unique thing called verification. Now, verifying is where you take your answer, you put it in the equation, and if the left side and the right side balance, then you know without a shadow of a doubt you have it correct. If you don't have the right answer, your verifying will not work. For example, I'm going to do the correct first, and then I'm going to assume we made a mistake and show you what would happen. So I've got x minus 4 is equal to 6. I said that x was 10. So take out the x, put in 10 in its place. Now what does 10 take away 4? That is 6. So we know that this stays balanced. Think of your teeter-totter or your pan balance. It stays balanced. So since 6 is equal to 6, we know we did it correctly. What if we did it the wrong way? What if for some reason I came out with a 9 here? All right, maybe I did 6 plus 4 is 9 because, I had a brain fart or something. So you're going to do formula, substitution. You're going to take your x out. You're going to put your 9 in its place. Now what's going to happen is 9 take away 4 is not 6. It's actually 5. All right? And what that means is you end up with a final line like this. And since 5 is not equal to 6, you know you've got to go back here and search for your mistake. If you have enough time on tests and quizzes, you can verify every one of your solutions, and you should be able to, assuming you do it honestly, figure out whether or not you actually have the correct answer or not. You can really mark your own test. Let's take a look at x minus 3 is equal to negative 4. So the first question is, what are you doing to the variable? You see, here's the variable. What am I doing? I'm subtracting 3. What is the opposite of subtracting 3? Add 3. So I want to add 3 to both sides. So I got x minus 3. That's what I started with. Add 3. Here I have negative 4. I'm going to add 3. You see the brackets right here? They're not needed, but they're just put in there to make sure you understand that it's a negative 4. All right? Now, a negative 3 and a positive 3. There's your negative tiles. There's your positive tiles. These all zero out. Negative 4 and positive 3 is negative 1, so x is equal to negative 1. Now, if we did it correctly, our verification should come out correct. So first thing you do is you always put down the formula or the equation. X minus 3 is equal to negative 4. And then what you're going to do is you're going to take out the x and put the negative 1 in its place. And if you do negative 1, take away another negative 3, you're taking away a total of 4. So in fact, negative 4 is equal to 4. How do I mark this? Real simple. Formula, substitution, answer. Your verifying is always worth 3 marks. Okay? Next question. Okay, so I've got x 13 this time with x minus 8 on the right-hand side. Don't switch it around. You're not allowed to. Okay? Later on, when we'll be doing a lot more equations, you'll get much more comfortable working on both sides. Nothing changes. On the right-hand side, you can see what I'm doing to the variable right here. I am subtracting 8. To undo or do the opposite of subtracting 8, you need to add 8. Okay, so 13 plus 8 is equal to x, take away 8, add 8. Now there's your positive tiles, there's your negative tiles. They become 0. So then I have x is 0, and 13 plus 8 is 21. So your answer is that 21 is your variable x. All right. Now you notice in every one of those examples what we did adding. There are four single-step equations that we learned last year. We can solve by adding, subtracting, multiply, and divide. And we're going to go over all four, and then we're going to end up going into what we call two-step equations. So let's go to the next one. This is solving by subtraction. So what's happening to my variable right here? I'm adding 3. What's the opposite of adding 3? Subtract 3. All right. So I've got x plus 3 minus 3 is 7, take away 3. Negative and positive tiles become 0. 7 minus 3 is 4, so x is equal to 4. All right. Now, you try one. Pause the recording and solve this equation. Okay, let's take a look. We are subtracting 4, so we have to add 4. So x plus a negative 4, there's my negative 4 tiles. I put my positive 4 tile with it and it'll go away. Whatever I do to one side, I must do to the other. Negative 4 and positive 4 will become 0. 5 plus 4 is 9, so x is equal to 9. All right, solving the next one. Now this is solving by division. So I'm going to do the first one, then I'll let you do the second one. What am I doing to the variable right here? If you look at it, I am multiplying by 3. So in order to undo multiplying by 3, I've got to divide by 3. Now, I need you, because we're going to be using a lot of numerators and denominators and fractions later on, we're going to stick with numerators and denominators. So you're not allowed to go 3x divided by 3. This will complicate us later and cause a lot of heartache. So we're going to stop that right now. You're not allowed to do that. What you do is you show 3x divided by 3 by putting the 3 under it. Okay? So what you're saying here is you have 3 x's. You want to separate 3 x's out into 3 distinct groups. Well, I got 12 on the right-hand side. I want to separate them out into 3 groups also. All right? Now, 3 divided by 3 is 1. So one of those x's is equal to 4. And that's where our grouping would come in. So x is equal to 4. All right? So let's have you try this one here, and then we will continue with the third one. So let's pause the recording and do the next one. Okay, so here we're dividing by 3. The opposite of, sorry, we're not dividing by 3. We're multiplying by 3. Opposite is divide by 3. So I've got 24, divide that by 3, and 3x, divide that by 3. 3 divided by 3 is 1. 24 divided by 3 is 8. So 8 is your x. All right? Okay, let's have you try the last one. Okay, now we're multiplying by 7. The opposite is to divide by 7. So 35 divided by 7. 7x divided by 7. 7 divided by 7 is 1. 35 divided by 7 is 5. So x is equal to 5. All right? So we've done the adding, subtracting. Let's take a look at this one. Whenever you see a fraction is a divide question you have yet to do. In fact, if you think about the divide sign looks like that. If you were to put numbers in here, that just means 1 divided by 2, which is 0.5. So a divide sign simply, the fraction is simply just a big divide sign. All right? There's your numerator, there's your denominator, and there's the middle of your fraction, just like you have like that. So whenever you see x over 4, that means you are dividing by 4. All right, let's go back over to the other side. If I'm dividing by 4, the opposite is to multiply by 4. So I've got x over 4 times 4. Now this is in the numerator, okay? Remember, all whole numbers have a denominator of 1, so you could put the 1 in here, but it's not needed. Whatever you do to one side, you must do to the other. Now, I'm going to do an extra line here just to help you out or show you. I don't think I did it. Yeah, I didn't have room here. It's going to move over here. If I were to put the 4 in front of the x, you see, this is the same thing we have right here. These simply cancel, giving me 1x. Right? Now the other side, I still have 32 times 4, and 32 times 4 would be 128. So x is equal to 128. Now if you're not sure, you want to find out whether you're correct, just take this 128, and for a second on your calculator, just do this calculation, 128 divided by 4. Do you get 32? If you do, you did it correctly. All right, here's one for you to try. 12 equals x over 5. You can see here that I'm dividing by 5, so to solve this, I've got to multiply both sides by 5. So pause the recording and finish this off. Okay, so I've got 12. I'm dividing by 5, so I've got to multiply by 5. X over 5, multiply by 5. I shouldn't put this x in here because other people will think it's a variable. So I'm going to do it this way with parentheses. Parentheses, when things are side by side, means multiplication. So 12 times 5 is 60. Now this cancels, giving me that 1, x, so x is the value of 60. Okay. Now, try the next one and then pause the recording. Pause the recording, then try the next one. All right, so here we go. You are dividing by 4, by negative 4, sorry. So to solve this, I've got to multiply by negative 4. So I've got x over negative 4 times negative 4 is equal to 2 times negative 4. These cancel, giving you 1x. And 2 times 4 is 8. And you remember your integer laws, a positive times a negative is always a negative. So x is equal to 8. All right? Sorry, x is equal to negative 8. A positive times a negative is a negative. Right? So if you want to double check, see you're right, just for a moment think of that being negative 8. A negative 8 divided by negative 4 is in fact 2, so we know we did it correctly. Okay, those were the 4 one-step equations, add, subtract, multiply, and divide. Now we have to do two-step equations. If you take a look here, these are a whole bunch of two-step equations. You can see here they're always the same kind of combination. You are either multiplying or you're dividing. And then you're either adding or that's an adding too, I guess, or you're subtracting. So you see that there's really there's only the 4 possibilities. You're either going to take a variable and add to it, or subtract to it, or you're going to take a variable and you multiply it and divide by it. So to solve these equations, we have to do the reverse order of operation. Now remember bed mass. This is what we did before. We'd always work this way when we're trying to solve an equation. But now when we're trying to solve an expression or I didn't get an answer. Since I want to go backwards, I'm actually going to go this direction. So I always have to add or subtract first before I multiply and divide, which is the opposite of bed mass. So let's take a look at what that looks like. 2x plus 5 is equal to 8. First thing I've got to do is get rid of the added 5. So 2x, if I'm going to add 5, I have to subtract 5 to undo it. So 2x plus 5, that's what's there, take away 5. What's there is 8, so take away 5. So that gives me 2x plus 0 is equal to 3, so 2x is equal to 3. Now you can see that I've now got a one-step equation involving multiplication. I'm multiplying by 2, so I have to divide by 2 to solve it. So 2x over 2 is equal to 3 over 2, so 1x is equal to 1.5, and x is 1.5. Okay, let's verify this. and see if we got it correct. So I said that 2x plus 5 equaled 8, and we said that x was 1.5. So let's take out the x and put in our 1.5. So 2 times 1.5 is 3, and 3 and 5 is 8, so we know that we did it correctly. It's always wise to double check your equations. Okay, so x divided by 4 minus 6 is equal to 24. I've got to get rid of the added or subtracted component first. So here I am subtracting 6. The opposite is to add 6. So x over 4, take away 6, add 6. To 24, I've got to do whatever I do to one side, I've got to do to the other. Now, a negative 6 and a positive 6 become 0. And 24 plus 6 is 30, so now I've got x over 4 is equal to 30. So when you take a look now, I'm dividing by 4. The opposite of dividing by 4 is to multiply by 4. So I've got x over 4 times 4 is equal to 30 times 4. All right, now, those cancel. So now 4 divided by 4 is 1x, and 30 times 4 is 120, so x is 120. All right. Okay, let's go to the next page. All right, let's verify. We said 120, so let's take out the x, put 120 in its place. 120 divided by 4 is 30. And 30 take away 6 is 24. So we know that we did it correctly. All right. Now things are reversed. I've got the variable on the right-hand side, but nothing changes. So I want you to pause the recording and I want you to try this one. Okay? So now I've got negative 3 is equal to 4m minus 8. Remember, I've got to get rid of the added or subtracted component first. So I've got to get rid of the subtract 8. To get rid of a subtracting 8, we have to add 8 to both sides. So I've got negative 3 plus 8, and 4m take away 8 is what I have. I'm going to add 8 to that. Here's my negative and my positive tiles. They become 0, and this here becomes a 5. So now I've got 5 is equal to 4m. Now, here I am multiplying by 4, so I've got to divide by 4. So 5 divided by 4 is equal to 4m divided by 4. These cancel, leaving you with 1m. And 5 divided by 4 is, you can leave it as a fraction, or if you want to have 1.25, you can leave it at that. So m is 1.25, 1 1/4. Now to verify it, let's go back to our equation. We said negative 3, I'll move over here so I have some room. Negative 3 is equal to 4m, take away 8. So we know that we want the m to be 1.5. All right? So 1.25. Okay, so negative 3. 4 times 1.25 is 5. And 5 take away 8 is actually negative 3. So we know we did it correctly. All right, turn the page. Oh, okay, well, we're ready to go. If you had any questions, go back and review it again and watch as many times. And if you need any help, you come in and see me. And we will see you next lesson.